Okay, let's start 13.1, the distance formula. So distance formula is a formula that gives you the distance when the line is not straight line. So if it's a horizontal line or the vertical line, you know you can just count the boxes or look at the difference in coordinates to see the distance. So this is 1 and this is 4. 1, 2, 3, 4, so difference is 3. When it's a vertical, this is 1 and 2, 3, 4, 5. This is 5, so difference in 4 and so forth. But this, you don't know the differences. So that's the distance formula. So, but if you look at this as right triangle, you know the distance here, right? So get the distance, and well, you know it's a 3 and 4, so distance should be 5. So this is 5, right? But let's just try to express this. So the 5 square have to equal 4 square plus 3 square, right? And 4 right here, if I call the coordinate of this x2 and y2, and if I call this coordinate of this let's say okay, I think it's better to call this x1 and y1. Okay, so this coordinate, the x is different, so let's call it no, this is x1, sorry, x1. This coordinate x and this coordinate should be the same, right? And y is different. Y is 1, but y is 5 here, so y is different. And then this coordinate, the x should be different, but y should be the same, right? Right? So if this coordinate is x1 and y1, this should be x2 and y1, and this should be x1 and y2. If you were to use these expressions, this distance from here to here, it's only, the y is not changing, right? So this should be x2 minus x1, right? This is a distance AT. And distance BT should be, x is not changing, but the y is changing, and it should be y2 minus y1. And this should equal 3, and this should equal 4, right? So the 3 square should equal this, right? If I change this coordinate to this. So this should be x square minus x1 square, this part right here. And this part here should be y2 minus y1 square, right? And if you add this should give you AB square, right? Because 5 is the distance between AB. So that's what this is. See, express the distance PQ using x1 and x1 and y1. So, you know, this is x1 and y1, this is x2 and y1, and this is x2 and y2. Okay, that's a little different. Y is the same and x is changing. This one, x2 and y2. Okay. Oh, because, wait. This is x1 and y2. Okay, so there is no y2 here. Okay, there's something is wrong. x1 and x2 and y1. Fine, because this is going up this way, that's why it's, but either way, this is a little bit different because this is going up, this line is going up this way instead of this. But anyway, the distance formula is generalizing this situation. So you can get the slanted line by taking the square root of the sum of the square of the straight lines, right? So this distance from here to here should be x2 minus x1, right? This is, y is not changing, x1 minus x2 minus x1. This distance here to here should be y2 minus y1. And I'm sorry, not square. This is 2, and this is 2. And then if you do square this, and square this should equal PQ square. So PQ have to be square root of x2 minus x1 squared plus y2 minus y1 squared. And that's the distance formula. So that's what we are learning. Okay, so distance formula is nothing more than Pythagorean relationship expressed in the coordinates of these points. Okay, and then because these are square terms, you have to take a square root, and since it's a length, you don't need to do plus minus because they have to be positive. Okay, all right, so let's look at objectives and let's do some problems. Okay, all right, so these sections have these objectives and these sections have these objectives. Okay, and we are here, but we already did this. We covered these sections in the previous or the prerequisite section that we already took a quiz on, and graphing linear equation and writing linear expression. We already did this. Okay, and we are not doing these sections. So after 3.1, we only have 2 more left in chapter 13, and then we're going to take a quick test. Okay, so the objective of this packet is to state and apply the distance formula. And there is also a circle formula. The state and apply the general equation of circle. I forgot to write this. Okay, so it's 1, no, is that 1, 2? Yeah, 1, 2. Was 1, 2. And is a state and apply? Yes, state and apply the general equation of a circle. Okay. Okay. And here's the theorem. So see the distance of between these 2 points is the square of the distance on the horizontal and square of the distance of the vertical, and take a square root of it. Okay, so here's some example. These are the coordinates. So this point, the coordinate of this point, the x value should be -4 and the y value should be -1, right? So between here and here there should be 4 and 2, so that's 6. And this is -1 to 2, so that's 3. So the distance will be 9 plus 36. So what? That would be 45. And square root of 45 is 3 to 5, so that's the distance. Okay. Alrighty. And here is example. All right. So find the equation of the circle with a center radius 4. This should, no, okay. Equation of the circle. Now that we know the distance formula, we can actually use the distance formula to get the equation of the circle. The circle being the equation is kind of strange concept for you because you don't associate the circle with like an equation, like what you know as an equation is like a line, right? Because you, I don't know, have you learned the parabola? Like y equal x square? I don't know if you learned that, but there is an equation for the circle. And the equation of the circle, if you put this in a calculator, you should get the line that makes the perfect circle, okay? But the line of the circle should be a collection of the points. This line should represent an equation the points that is equal distance from the whatever the center is of the point, equal distance. So this is 4, this is 4, this is 4. The collection of all these points that is distance is 4 from this point should give you this line, right? So that's what this is. If you pick the random points and then coordinate of these random points, we call it x1 and y1, and then all these points we call it the coordinate x and y. Collection of the points should be this distance should be 4. So x minus 5, because let's say if this is here, this is x and then 5. So this distance should be x, this value x right here, and then 5, this distance should be x minus 5, right? And then this y, let's see if y is here, this distance here should be y minus 6, y minus 6. The square of that plus square of that should equal, the square root of it, should equal 4, right? That's what, if you plug this in, if this is the equation, any x and y value on this line should satisfy this, right? Because the circle means the distance is 4. So no matter which point you pick on this line, the x and y coordinate you plug in here and should give you 4, right? So this is the equation of the circle, but we usually express it with a squared term instead of a square root term. So it's the x minus the coordinate of x squared plus y minus the coordinate of 6 equal radius squared. So this, if you plug in any x and y value on this line, should satisfy this equal, because it should be. That's what the circle is. So that's what this theorem 13.2 is. Okay, and the equation of the circle is center AB with radius r is x minus a squared plus y minus b squared. Now, I noticed on the quiz that you did that some people confused about the difference between x and a. And because you haven't done algebra in a while, but you remember, x and y are variables, okay? So if you write in the equations, those have to stay in equations. A and b are constants, means that it represents some kind of number that doesn't change. Okay, and then that's how we choose the x, y, and z usually are the variables. Those are the ones that will change. So, like for example, if this is the equation of the line, right, the x, y value is changing, right? But the intercept doesn't change, and slope doesn't change, right? So those are the number that is not changing, and x and y changes. Those are called variables, and these are called constants. Okay, so in this case, the center of the circle is not changing. The x and y value is changing as we move along the point on the circle, and this is also a constant radius in this case. In this case, the only variables are x and y. So those are the changing, these are constants. Okay, and we are using r because it's radius. Okay, all right. So if the center is 1 and negative 2, and the radius, find the center of the radius of the circle with the equation 1 and 2, sketch the graph. Okay, so if we don't have a solution, this means the center have to be, you change the sign, right? So it's 1 and minus 2. That's what this is, and radius is 3. So this should be 3, this should be 3, this should be 3, this should be 3, and so forth. Okay, that's what it means. The center is 1, negative 3, and radius is 3. Okay, so the rest is a practice. So let's do a few of these together, and then we do the rest in the class. Okay. All right. So what is the x coordinate of every point that lies on a vertical line through C? Let's see, vertical line through C. What is the x coordinate of every point that lies on the vertical line through C? Well, it's 1, 2, 3, 4. So it should be negative 4, right? X coordinate is always minus 4 if it's a vertical line from C. Which of the following points lie on the horizontal line through C? So anything that has y equal 1, 2, 3. What is it? 1, 2, 3, 4. So any of these that have y equal 4 lies on the line. So it's this, this, and this. Find OD and BF. OD, that's 2. And BF, well, that's 1, 2, 3, 4, 5. Okay, so these we didn't have to do. You knew what you were doing. Okay, exercise 4 through 9, state the coordinate of T and the length of the leg of the right triangle and the length of the segment shown. Okay, so this is good. You can practice with this. So I want you to do 5, 7, and 9 and practice that. Okay, and let's do, I'm gonna do this one and this one right now. Okay, and I show you some of the, I see that this one there is a shortcut there. Okay, I'm not sure about this one, so let's try this one first. Let's see. this was, so this, well, let me just see. This is 5 and 1. So this is 3 and this is 4. Okay, so there is a shortcut there for this one. Let's just do this one. We'll do all this. All right, so this coordinate, y should be 2 and x should be 5. So the distance is 1, that's 4, and then 2 to 5, that's 3. Oh, this one is another shortcut one. You didn't have to use the formula. And this one, you see it's, okay, so the coordinate of here is -3 and -3, right? So you see that this is 6 and this is 6. So this distance, this is 45, 45, 90 triangle. So this distance will be 6√2. Okay, so this one you didn't have to do the distance formula. I'm not sure if any of these is actually, no, it's not. The special right triangles of the 60-30 variety, you're not going to get this because you're not going to get the whole points for the coordinates. So these three, I'm sure these are the formula one. So let's just do it, this one together. So at least we do one example that we have to use formula. So this coordinate, the x coordinate should be -3, right? And the y coordinate should be -2. So this distance is -3 to -1, so that's 2. And this distance is from -2 to +2, so that's 4. Okay, so because this is half, don't think that this is a special right triangle. The double of the short leg has to be hypotenuse, not the long leg, right? So this is not a special right triangle. So this should be square root of 4 square plus 2 square, right? So that means that's square root of 16 plus 4, square root of 20. So that means 2√5. Okay, so you do 5 and 7 here. And here, find the distance between the points named. Give all answers in the simplest form. Okay, you can do this one. Homework. And find the center and the radius of each circle. Okay, you can do this one. You can practice that. Why don't I do A and C and you do B and D? Okay, and find the equation of the circle that has a given center and radius. Okay, you should do this one, but I'm going to do these two, especially this one has a J and a K and an N. Okay, and I think we can do rest in the class. Okay, so you can do this one. You got the 2 points and you just plug into the formula, so do practice. Okay, and then this one, the center for this one, 11A, is x coordinate is fine, that's 2, right? Because it's -2, you sign the change. And this one, there's nothing there. So that means it's 0. Okay, so the center is 2 and 0. And this is radius square, so radius should be r equal to 1. Okay, and the C. Okay, the same thing, x here is 0. And y is -5. And the radius is square root of 112. Let's see. What can you divide this by? 3? No. 2, right? 56. 2, 28, 2, 14, 2, and 7. So 4√7. To 12B and D. Okay, so 12B. That wasn't, yeah, A and C. Okay, center of this and radius 5. So x and x coordinate, change the sign, so that's +2 square plus y -0 is 0, nothing changes, so y square equal 5 square, 25. That's the equation that has a center this and a radius 5. And 12D, center JK and radius N. So the center is x minus j square plus y minus k square equal n square. That's it. Okay, so you can do these, and then do these 3.